So we are going to learn about the analysis of propped cantilever. So what is a propped cantilever? A cantilever beam is supported by a prop, that is called propped cantilever. A cantilever beam supported by a simply supported condition, or a cantilever beam simply supported. So these are the different schematic diagram for the representation of propped cantilever. So there are many analyses for the finding the deflection, bending moment, shear force of propped cantilever. A very simple method is the theorem of three moments. Already we have familiarized with the beams of two span using theorem of three moments. The analysis of beams of two spans with the theorem of three moments. So for the theorem of three moments, we need at least two span. We need at least two span so that our equation can be written with the MA, MB and MC component. But for the propped cantilever, there is only one span. How it can be done with the theorem of three moments? An imaginary support is considered on the left side to create two spans. Let us see one by one. So the application of three moment equation in case of beams when one or both of the ends are fixed. First considered we are fixed at only one end and hinged at the other end. The beam is loaded with the UDL. So consider an imaginary point A dash on the left side of the beam so that it will create some imaginary length of 0 meter. Imaginary length of 0 meter. Consider the length here L1 is 0 meter, L2 is L. Okay, as a is fixed support, extend the beam from A to A dash of span 0 length and A dash is simply supported condition. The simple beam bending moment diagram is a parabola. We know simple bending moment diagram or free bending moment diagram for a simply supported end with a UDL is a parabola. Consider it as a simply supported beam with a UDL. So it is the first step for theorem of three moment, W per meter. So it is a parabolic equation of WL square by 8. The centroid of this bending moment diagram located at L by 2 span from both the supports A and B. So next, the area of the parabola from the span A to B. It is 2/3 of length is L and the ordinate of bending moment is WL square by 8. So totally WL cube by 12. And our final bending moment diagram for this propped cantilever is, so it is a support condition. So in a simply support condition, the bending moment is 0. In fixed support condition, we have some value that is MA and connect to the points. So this is the bending moment diagram. The support moment diagram is like this. Apply three moment equation for the span of A, B. How? Consider A as the intermediate support. Consider the A as the intermediate support and A dash as the left side support, B is the right side support. So M A dash into L1, that is 0 span, plus 2 MA into L1 plus L2, that is 0 plus L, plus MB. It is a simply supported condition, hence it is 0. Hence it is 0 by applying the boundary condition. So it is mentioned as 0. So directly we get the right side equation as minus 6 A1 x1 bar. Minus 6 A1 and x1 bar. A1 is WL cube by 12. X1 bar is the midpoint of the parabolic bending moment diagram L by 2. So directly we get MA is WL square by 8. MA is WL square by 8. So the negative sign indicates the anti-clockwise direction. The negative sign indicates the anti-clockwise direction. So it is mentioned here, WL square by 8 loading is mentioned here. For a fixed support, it is having a vertical reaction and a moment and a horizontal reaction. In this problem, there is no horizontal force. So we need not bother about this horizontal reaction, only concentrate on vertical reaction and the moment. So we have calculated the moment value as WL square by 8, anti-clockwise direction, and VB is there. Our aim is to find VA and VB. The analysis of a beam means to find reactions and bending moments, and also some problem to find slope and deflection. So you have studied in mechanics of solids to find the slope and deflection for a basic type of structural elements. So how we can calculate the reactions? First of all, you familiarize with the this equation. The total vertical load is shared among the support reactions. So VA plus VB is equal to total load. What is the total load? For the UDL, UDL magnitude into the length, the span of the loading is the total load. So W into L is the total load. So we have one equation, VA plus VB equal to W into L. This is one equation. Another equation, we can take moment about A equal to 0 or B equal to 0. If you take moment about A equal to 0, how you can write? VA into the perpendicular distance L. I am considering BA as positive. The load is rotating opposite direction to VA. So minus WL square by 2. W into L is the loading and centroidal distance is L by 2. And consider this is moment. There is no need of multiplying the distance with the moment, because the force is only to be multiplied with the distance to get the moment. Here it is itself is a moment value. So directly consider the sign convention. So the sign convention is similar to VB. The sign convention, if you rotate along this direction, it is similar to VB. So it is a positive quantity WL square by 8 equal to 0. That is, I am taking moment about A. I am taking moment about A equal to 0. So VB into perpendicular distance, VB into L, not VA into L, it is VB into L. So VB into L is rotating particular direction, and the loading is rotated in opposite direction, and this moment is rotated in the same direction of VB. So these two quantities are positive and the loading quantity is negative. So with this equation we can find VA and VB. From this equation we can find VB, and substituting this total load equation we can find VA. The same is repeated here. The total load is distributed among the support reaction, and VB into L, this load and this one is both moment, both are having same direction. So if you solve this value, you get VB equal to 3WL by 8, and if you substitute VB in this equation, you get VA equal to 5WL by 8. So the shear force diagram, VA from A, it is 5WL by 8. VB is downward, so it is 3WL by 8 to just connect both the lines.